To extrude raw aluminum into a specific form or shape requires careful preparation and assembly of key components to safely generate high-quality aluminum parts. First in the process is to lay the die assembly ring flat on the workbench for all parts of the die stack to be inserted and assembled. Looking down into the ring is looking from the entry side down through the exit side. To start the stacking process, first a feeder plate is inserted with the outer ring step facing down. This ensures proper seating in the ring. Notice the left inside of the ring as the feeder plate is inserted, the technician has the feeder plate aligned with a keyway slot. The keyway slot will become an important tool for aligning remaining parts. On the opposite right side of the feeder plate there is a pinhole. In some instances the depth of the die stack does not allow for the keyway to be fully installed. To keep the plates from spinning while in use, the following die plates will have a pin that aligns into the pinhole, creating a locking bond between the multiple plates. The technician then inserts a keyway alignment tool. This will allow all further plates to quickly align with all other parts of the stack. With the alignment tool in place, the technician now preps the die by removing the adhesive film from both the entry and exit sides of the die plate. With the film removed, it is crucial to identify the milled control pocket, which is the entry side of the die plate. You'll notice all of the enclosed details in the control pocket, which controls the flow of material in the die stack. The exit side looks similar but more open. At the top of the die plate, you'll notice the pin opposite the keyway slot. Once the die plate has been correctly oriented, the technician is ready to align the die plate with the keyway alignment tool. The die plate should drop cleanly into the ring assembly. If it doesn't, it is okay to use a hammer or mallet to gently tap the die plate into the ring. If the die plate doesn't drop in, it is critical to not sledgehammer the die into alignment, as this can cause dies to break, damage the keyway, or can cause production run inefficiencies. With the die plate installed, the technician is now ready to install the final piece of the die stack assembly called the backer. Much like the other plates in the stack, it is crucial to properly identify which is the entry and exit sides of the backer. Notice how the technician initially identifies the exit side. This side is again the less detailed and open shape of the die. As the backer is reversed, you'll notice the entry side of the backer, which features several grooves called nitrogen grooves. The nitrogen grooves allow nitrogen gases to displace any other gases, specifically oxygen, from making contact with the extruded materials, which can cause oxidation of the aluminum surface. Between billets, the nitrogen gases also help to cool the die plate, which helps extend the life of the die. As with the die plate, the pin is at the top of the backer opposite the keyway slot. With the entry side of the backer properly identified, the entry side should go facing down into the ring, making contact with the die plate. This completes the die stack with the exit side facing up at the technician. With all plates installed, the keyway alignment tool can now be removed. In its place, the keyway can be fully inserted. Otherwise, if it's too long, the keyway can be omitted. The keyway should naturally want to go in with little influence and force. If excessive force seems to be required to install a keyway, the keyway ring or backer should be sent to the die shop immediately for inspection. Forcing a keyway into the slot can cause the keyway to jam, causing production delays and potential damage to the parts of the die stack. With the die stack assembly complete, the technician now attaches a clip to the outer wall of the ring for the chain lift to connect. Each die stack is stood upright to be moved prior to moving the assembly. The technician uses a piece of chalk to mark the ring's exterior with the die number and copy number. Before the die stack can be moved on, the technician must clear the stack. This is a process of visually examining the stack's alignment to confirm the stack is ready to properly produce extruded metals. Starting by visually looking through the exit side, the technician checks to see that the backer and die are properly aligned and that the backer is able to accommodate the size of the material passing through the die plate. Spinning the assembly 180 degrees, the technician observes the die stack through the reverse orientation. Looking through the entry side, the technician looks to see the shape of the die and identify the control pocket and bearing. With the chain hoist connected and the stack cleared, the technician uses a remote to maneuver the die stack to an oven where the die stack is heated to a set temperature that prepares the metal dies and plates for production. Depending on the amount of time required to heat the die stack to a temperature, may require multiple technicians to work with the same die stack. Because die heating cycles sometimes overlap work shifts, it is required that the die stack be re-examined coming out of the oven. This second round of clearing the stack surfaces is a double check to confirm the die stack has been properly set up and assembled. Again, this is especially important if the technician pulling the die stack out of the oven was not the same technician who assembled the die stack before being placed in the oven. After clearing the stack a second time, the assembly is ready to be paired with a second large ring called the bolster. The bolster helps control the freshly extruded metals exit the press onto the rollers. Because the bolster is in contact with the metal, it, like the die stack, must be heated to a set temperature, typically around 400 degrees Fahrenheit. Keeping the bolster at a consistent temperature will help prolong the life of the bolster. With both the die stack and bolster connected to the chain hoist, the technician is now ready to move the assembly set to the press's saddle. As the assembly approaches the saddle, it is important to note the backstop and keying bar in the saddle. The entry side of the die stack has a step edge that aligns with the backstop for proper seating. The keying bar in the bottom of the saddle also helps to seat the die stack assembly and prevents any of the parts from spinning during production runs. The technician lowers the assembly into the saddle and double checks the assembly is slid fully back into the backstop. The technician now has two final and crucial tests before deploying the die stack assembly into the press. The two most important elements to check prior to operation are temperature and clearance. With the chain hoist removed, the technician performs a third and final clearance check of the assembly. The stack is cleared once again from the entry side and the exit side. Following this, the technician must check the temperature of the bolster and die to prevent damage to the assembly. If the assembly is not at temperature, the materials must be reheated before being deployed for operation.